Yeah, so as you mentioned, my name is Michael Gregory. I work for Astronomer. If you're not familiar with Astronomer, we are the corporate entity kind of backing up and building Apache Airflow, as well as we have hosted offerings, commercial offerings as well. Everything I'm talking about today is really around Airflow, obviously, and the community efforts there. Just have this up here, just maybe a quick show of hands. Anybody want to build along with today? Like, you should be able to, if you want to, be able to get all the way through to a full implementation. That's also fine. All right, well, that's good. So we can move through it quickly. That's fine too, because I'm going to walk through a lot of it. You'll have the gist of it. You'll understand kind of what's going on. And then you can always go and build on your own when you get back. So first step, maybe just quick question. Everybody who's not familiar with Apache Airflow? All right, one or two, that's good. That's a good start. Who's not familiar with Astronomer? Yeah, that's the other side of it. So yes, we are one of the biggest backers of Apache Airflow, and based in the US. I'm from the US as well. I live currently in Amsterdam, where I've been for, well, I guess I've been here in Europe for the last 17 years or so. And I currently work on basically building out everything with Airflow, specifically on the ML and AI side of Airflow. Everybody kind of knows Airflow as a great tool for data engineers and for data orchestration. And then as we talk to a lot of organizations, everybody seems to be using it for ML ops as well. And so my focus is on building features, functionalities, stories, successes around the ML side of that. So that's kind of my niche area of focus. And obviously when LLMs come around and everything generative, things start getting interesting as well. So if you are planning to build and do any of this today and those steps, I'm not sure how fast the conference Wi-Fi is. If it's anything like the hotel Wi-Fi I had, you may have some difficulties getting some of that downloaded. But like I said, we'll walk through it anyway. So this is all about operationalizing retrieval augmented generation. If you came to learn about all the magic involved with LLMs and all the wonderful things and how all the things work with prompt engineering and things like that, this is the builders, the makers part of the process, where somebody's got to put things in operation, productionalize these workflows, these ideas that people are coming up with. As you mentioned, that's me. So I guess the story really kind of starts here. This is a fake IRL chat, a real chat. If you're in this room, there's a good chance some business leader came to you at some point and said, these LLM things are awesome. I hear about it all in the news. My own mother knows about it. Why aren't we doing anything? Should we be doing something with LLMs, right? Or an intern within the company says, hey, I built this great prototype with LangChain in a notebook. Now let's make it production. And so there's a big gap between kind of building a prototype and putting everything, kind of making sure it works and things kind of functionally work. And you can kind of see the power of these LLMs right off the bat very quickly with technologies like LangChain and Llama Index, et cetera. But there's a gap from that to production side of things. I just want to check that's flickering. Is that on my laptop doing that? Is there anything I need to do? No? Okay. I think that's the sign that they want me to move faster. That's great. So this is going to be a builder's kind of hands-on tutorial. I will show a couple slides to tee it up and what we're talking about here, but there is going to be kind of coding. So the genesis for all this started in the same place as that chat. One of our engineers internally said, hey, I went out over the weekend, I was bored, and so I built a chat bot, a Slack bot. A Slack bot for Astro, for everything Airflow related and Astro related. It's kind of cool, works really great. All of our engineers jumped on it, our customers jumped on it, they said, this is fantastic. Now, they looked at me and said, now go put it in production. So in order to do that, some of the things that you maybe run into if you're in the same spot, obviously there's a lot of work that needs to be done in the experimentation process. A lot of the chaining technologies and the LLM applications today is still fairly new, and there's a lot of experimentation that needs to happen. You need to be able to try things and try things and try things. And so you want to set yourself up with that flexibility to be able to do that. Obviously, once you get things working, you want it to be a lights out, automated, production quality, audited, governed lineage, all that stuff that needs to go into building, scheduled or ad hoc workflows. You need to be able to try different chunking strategies, different models. The new, like when GPT-12 comes out in a year or so, whenever that's going to be, be able to switch and try new models as they come out. And this was an important part as well. Being able to retry things. A lot of the applications, endpoints, either for data sources or the models themselves are slow or finicky, or there's API rate limits that you need to deal with. And so being able to retry things is important. Being able to apply different types of compute to different parts of the workflow, and then just be able to basically to create standard interfaces that are going to be used both for the front end and the back end, et cetera. And so these are like just at a high level, some of the things you run into when you're starting to do the operational side of the LLM applications. And of course, if you worked with Airflow before, you know that this is a sweet spot. This is what Airflow is designed for. And maybe not having anything specifically to do with LLMs, but really the processes, the practices, the foundational pieces, the infrastructure that you have in place today applies to a large portion of the application workflows that we're going to talk about, including things like data governance and fine-tuning and building feedback loops. We're going to talk about that as well today too. So we looked at all those challenges. We looked at this use case and we said, this looks an awful lot like this. So Andreessen Horowitz put together this emerging stack that they put together. They looked across the industry, pulled together all the different tools that people are using to build these workflows. And if anybody here is from A16Z, I apologize, I forgot the link on the bottom, but this is theirs. This is their stack that they put together of all the pieces there. And obviously Airflow is kind of sprinkled throughout here or has an important part to play in all of it. So we wanted to build something that was going to make not only kind of solve this internal use case that we had to do, this particular use case, but we wanted to do it publicly. Obviously, we are a steward of the community within the Apache Software Foundation, and we wanted to do it in a way that whatever we're building, people can take advantage of. And so if your boss comes to you and says, hey, we want you to go and take this thing into production, this intern handed me a Jupyter notebook, now go make it in production. A starting point, or at least a template, something you can get started with and say, okay, I can build from there, customize it, and use it for my use case. You don't have to start from scratch, you can kind of start from this. So that's one thing we want to be public, but also to drive some communication and some dialogue with the community around this. As we start saying, as experts in here, we're saying, this is great, or we really need to build the tool sets around these weaknesses, or that's a pain, we need to do that better. So it's very much meant to be a community-developed asset. We want your thoughts and input and ideas on it. We're starting things, we're making it available to everybody to do that. So a lot of what we're going to talk about today is really kind of how to use this tool, how to use this template, and like if you wanted to pick this up and use your own use case, we'll kind of use that as the thread throughout the process here. Maybe just a quick introduction when we talk about RAG, or retrieval augmented generation. I'm assuming if you're in this conference, you probably have a very good idea what it is. There might be some people here that came for the coffee. I haven't even tried the coffee yet. Is it good? Probably good. Just in case, we'll go through this very quickly to see what is this thing called RAG. As you know, LLMs obviously trained on some huge amount of complex training data. There's a whole bunch of super secret magic in there, and then there's an amazing API that comes online, which you can ask questions or make it draw pictures for you of yourself. If that's what you're interested in, that's not what this talk is about. And one of the main reasons is the work that goes into just like leveraging and using these LLMs today. They're amazingly powerful. And basically the work is around building and creating creative prompts, asking the model to do various things. And there really is a lot you can do with just asking them different questions of the various models that are out there. But from an enterprise perspective, and I assume probably most people at the conference today are either working for a company or in the commercial kind of industrial world, there's not a lot of competitive advantage in that. Meaning, if you're going to build a business and you're going to get really creative about prompts for this model, there's not a lot of barrier to entry for other people to do the same thing. Really, for most organizations, their competitive advantage is in knowing their market, their industry, having a set of industry knowledge that's tied up often in their data. And so retrieval augmented generation obviously is the process of leveraging that data that you have as an organization in order to create something unique that other people can't create. Essentially, it looks like this. You got a bunch of data sitting somewhere in your business. A lot of it's unstructured. Taking that data, ingesting it, splitting it up into chunks that are valuable, storing that in a vector database, retrieving that from the vector database, and using that as context when you ask the model for, when you do a question and answer with the model, with the LLMs. So you're basically infusing your intellectual property, your knowledge, your market expertise into that prompt and making it better. So it's the augmentation of it by retrieving from your own local systems. The 2010 million foot view here, if you're not familiar with vectors and embedding, you take a chunk of unstructured data, run it through an embedding model, and it generates and spits out this magical vector, which is a context-aware representation of that data in numbers. Much, much more complex than that, but just for the sake of, if anybody's not familiar with it today, to give the idea. So you can take a question and build a vector from a question, and you can take a vector from your own documents that you created, and you can do something like cosine similarity. There's others as well, but kind of the basic one to say these two documents are related. This is not a text search. You're not actually searching for the word Bambi in your books, right? It's actually, it's related to concepts and ideas in creating a nearness evaluation of how close these things are, how similar they are. So obviously one of the components to make this happen is a vector database. A lot of the chaining technologies that are out there now, things like LangChain, Llama Index, Haystack, I think unstructured, there's a lot of them are out there right now, and they're very powerful tools. They often start with the idea of an in-memory vector database. So it's just basically taking these vectors and keeping it in some kind of in-memory thing. Obviously that has scale limitations and performance and all kinds of things there. It's great for prototypes, but when you go to a production environment, obviously you need a stable, reliable, scalable, long-term, efficient database of storing these vectors in them. And so the vector databases, if you're not familiar with it, for this particular workflow, we picked Weaviate. It's an open source vector database implementation. Great team at Weaviate building there. There's absolutely no reason you couldn't build a lot of this with, and we will be shortly doing implementations, Pinecone, PG Vector, Chroma, Milvus, another great one. So there's lots of options out there. We chose Weaviate 1. I'm based in Amsterdam, they're based in Amsterdam. Pretty tough technical decision. But also they have a great open source model. They have obviously, so an open source base with a hosted offering, which is very similar to our own business model at Astronomer as well. So that's kind of why we started with them to begin with, but there's lots more coming, like I said, with other ones. They have nice integrations with OpenAI, Cohere, Hugging Face, and other models kind of directly in Weaviate. And they have a fully hosted version, like I said. And they also have a Docker containerized version of Weaviate, which is really great for local development, which you'll see today. And it really snaps in very well with the Astronomer, the Astro CLI, which I'll be showing you as well for just great kind of local iteration development process. And then also snapping in with your dev and your CI/CD processes to be able to promote between dev and test and prod, et cetera. We did build a Airflow provider for Weaviate. We did a webinar with them recently, and so that's out there on our Astro website if you're curious. So it gives a nice kind of very clean interface between Airflow and Weaviate. Very nice building blocks there. And that's going into the Airflow community along with new providers for OpenAI, Cohere, Pinecone, and PG Vector. All those providers will be going into the Airflow open source here very soon. So, but again, we started with Weaviate just kind of as a starting point for what we wanted to build. So where does Airflow come into this? You saw kind of this graph before, this portion of the retrieval augmented generation pipeline. This is obviously exactly what Airflow is designed to do. Take a bunch of data, ingest, transform, process it, make it available in a place in a very highly reliable, audited, governed way. And so in many cases, Airflow was a perfect fit for this out of the box. There were some things we needed to be able to build around it to make it a little bit more comfortable for these unstructured data sets like we're doing here. But for the most part, it was an obvious choice, as Andreessen Horowitz mentioned in their write-up as well. But we wanted to, like I said, to build a kind of a template for how to do that. So Airflow, I think there was a couple of people that weren't familiar with it, but it's Apache open source project. Currently, I think it's still the biggest and most active open source project ever in Apache Software Foundation. Probably doesn't include Linux, I guess, but it's Python-based. It's got all the hooks and things you need in an enterprise orchestration environment for monitoring, alerting, the ability to kind of plug in different types of compute to make it work. You get a nice common interface for different teams, whether you've got data engineering or ML teams, data science teams, et cetera. It's very extensible. There's currently 1,534 modules for everything from whatever database you want to plug into, whatever object storage, cloud provider, upstream open source web frameworks, etc. Very, very extensible. And this is really kind of the superpower of Apache Airflow, as you'd expect from an orchestration framework, right? If you're sitting, basically the orchestration tools within the stack are what the glue that kind of pulls everything together. And that's really where Airflow sits in there. It is data agnostic, but it is data aware. And there's a lot of new things that we're developing and putting into the framework now to make that even more so. And so it's really kind of a great fit for RAG-based workflows, this document parsing, ingesting, and all the stuff you have to think about other than just a notebook running that you want to periodically run the notebook every night to pull it in. So just to give you an idea how big it is. So 16 million monthly downloads. I think that's now up to 17. 29,000 members, 2,600 contributors across a big swath of different technologies and providers. And then, like I said, 1,500 modules for plugging into anything that's out there. So this became, like I said, the reference implementation that we wanted to put together for Ask Astro. Ask Astro is a tool that came up. One of our engineers, like I mentioned, I think he got tired of getting asked the exact same questions over and over and over from community members, et cetera. And so he said, I'm gonna make a bot for myself. And I think he wanted to go on vacation once in a while instead of just working all the time. So his solution was to make a Slack bot out of it. The problem statement was this, the Airflow community is very, very active. There's lots of documentation spread out all over the place. And so it's very tiring sometimes to look around and try and find the answer that you're looking for. There's stuff in Slack, there's Stack Overflow, obviously, multiple websites. The Airflow docs themselves are very rich. Our own Astronomer docs, if you've not seen them before, they actually go in a lot more depth on Airflow from the Astronomer website. And we got many different, just spread out over a bunch of places. And this comes from being such an active community. If you ask a question, you're going to get an answer, but it could be anywhere. So as a user, having one kind of single place to go to say, what is the input function for dynamic task mapping, whatever. Having one place to go there and do that. It started as a Slack bot, like I said, which we then extended out. So give you a high level of what the ingestion process looks like. And I think this is an important kind of first step in philosophically thinking about LangChain LLM operationalization, which is to really separate the front end from the back end. Like I said, you can do it all in one Jupyter notebook right now, and just it goes through all your cells and runs the entire thing, including the prompt and all the front end stuff as well. As you look at operationalizing it, though, it's really important to kind of draw a line right at that vector database and treat the back end, what I call the back end, is everything up to feeding data, vectorizing it, embedding it, putting it in that vector database. Treat that as one piece of work. Often that's going to be in your data engineering team. And then the front end, which is now using those vectors in order to do things like prompt engineering or front end applications, very likely it's going to be a different team in an enterprise environment. If you're a startup like this, one person kind of does everything, which is not great. But so on the back end, the ingestion process, which is what we're really going to talk about today, taking all of these various document sources out there. Some of them are in web pages, blog posts, Stack Overflow, Slack messages, etc., and document the actual documentation, pulling that all into and extracting all of that. We do use, in this particular code, we just picked to start with LangChain for the splitters. They've got several document splitters. If you're not familiar with splitting, basically the models that are out there today, and especially I think GPT-4, if I remember right, has a 32K context window, meaning the question that you ask GPT-4, you can have 32,000, I think it's 32K. So it's limited. You can't just spend, if you're just asking a simple question, obviously you're not going to run into that limit. But if you're saying, look into my corporate database of 20 million loans from the bank, find all the ones that are relevant, and then send those over to my context window with my question that needs to be asked of it, it's very easy, very quick, you can run into that context window. So splitting basically takes very large documents, splits them into chunks, and then use those chunks to be able to fit in a context window. So it's really all about that. GPT-3, I think 3.5 Turbo was half of that at 18K, if I remember right. And then we expect they'll probably get bigger, but even still, if you have like some of the documentation from Airflow, it's like, 50 pages long of text. And these are technical documents which are already kind of split up and indexed already. But if you're using any kind of non-technical documents, medical documents or anything, we did a use case recently with 10K filings for the IRS, the tax in the US, the tax agency in the US. These are 200-page long documents. Obviously, that's not going to, it doesn't matter how big your GPT-5 or 6 context window is, it's not going to fit in there. So it's very important to split the documents. But the splitting, the strategies you take and how you split those up is very important. You don't want to just randomly split in the middle of a word or in the middle of a paragraph, etc. So again, I guess if you're at a generative AI conference, I'm assuming this is pretty well known, but that process of splitting, you'll hear me talk about it quite a bit today. There's very, very rarely a right answer, and very rarely will you get it right the first time as you're working on these use cases. And so setting up your frameworks and your processes to be able to iterate on that and try different things is really important. So again, we tried LangChain. We used LangChain. The initial splitters we used was a Markdown text splitter. Maybe back up a little bit. In the initial implementation, we decided to standardize on Markdown format. So whatever documents they were in before, like a blog post, just a bunch of text in HTML, converting that into a Markdown format, taking RST documents from the Airflow docs and converting that into Markdown. And the main reason we did that, GPT-4 is actually quite good at understanding Markdown structure and also generating Markdown structure. So when you're going to visualize that or present that on the front end of your UI, doing that in Markdown is actually quite easy to do with a lot of the models that are out there. There's no right answer here. This is what we chose. And so all of these different document sources you'll see in the instructor modules that we build basically convert it into something that looks like a Markdown document. #1 for a header, #2 for 2 headers, etc., and kind of artificially generated Markdown documents from that. Again, maybe not the right thing to do, maybe not the best thing to do for every use case, but just to give an idea of what's a way to do that. So we started actually with the LangChain Markdown splitter. It's quite good at going through documents, it'll split those chunks based on the headers, the Markdown headers, in order to split up the documents. It turns out we didn't get very good results with that at all. I was kind of surprised because we were infusing structure in the documents, and we thought would get us a good response. Because when we do that similarity search, we want to find the chunks that are most important for that particular answer in a question, right? So we went back to a recursive character splitter, a very basic splitter, which splits more like on a paragraph level or something like that, and got much better results. Again, it's a template, so it'll change over time. And whatever use case you would be building, you might want to try something else. Most importantly is set up this entire workflow so that you can try different things and see how they work. We use OpenAI endpoints for embedding model to generate the vectors, and then stored it in Weaviate, like I said. On the front end, now this is not specifically Airflow at this point, the front end, we wanted to, because it's in a vector database now, we can use different front ends, like a web app, a Slack bot. There's a Streamlit app that's integrated with the workflow as well, so you can test something just very quickly without writing a lot of code. Different front ends, and then use different chaining technologies. So the UI, the app that's in there right now, let me just show you. I should have shown that right from the beginning. Anybody have an interesting question about Airflow we can pop in here? Yeah. Dynamic tasks. We'll just do something like that. So you can hit that. This is a public website, ask.astronomer.io. If you're using Airflow today, I use it all day long to ask stuff. I don't even bother going and looking through the docs anymore unless I know exactly which page it is. I use it all the time to ask questions. It's very, very good in the responses that it gets for the most part. The latency there, by the way, is really GPT-4. So GPT-4 itself is quite, it's slow. Very powerful, but slow. And so obviously we ask a question, we get the response there. And it's actually, of course, I know this one's right because I might have written the doc that it's hitting here. I'm not sure, but so how does that work on the front end? We take the original question. My question was, how do you do dynamic tests with Airflow? And we actually tell GPT 3.5, which is much faster and a fraction of the cost of GPT-4. We say, GPT 3.5, give me 3 versions of the same question. So take this question and give me 3 other versions of the same question. Then we do a similarity search within our document store for each one of those 3 questions, and then use those 3 questions with the top 5. I think we do a top 5 response. So basically, when you do the vector search, it'll say, here's the 5 most relevant based on the cosine similarity, and it ranks them in order. So we do 3 versions of the questions, 5 answers each, which is based on these chunks of data. And we send all that to GPT-4, which has a much bigger context window, slower, more expensive, but very powerful. And then you get to summarize that. We say, use all of this context to answer that question. And we get, as you can see, try it out for sure. Try it yourself, but you'll see very good responses on that. Again, is this the right way? Like, there's tons of work being done into different ways of doing this. This is one way, and you can try it out yourself, try different approaches, etc. That's on the front end. The last piece is really the feedback loops. This is another part of operationalization, which is in the app. I don't know if you saw here, there's an option for thumbs up, thumbs down, or yeah, they changed it. Is this correct or not? Every time I click on that, we're capturing that information, and we're going to use that now to continually make our data store better over time. And so actually, if you look in the repo today, there's not a lot on this right now. It's kind of in development right now, but it's an extremely important part of all of this process to be able to go back over time and feed it. There's a couple of hallucinations, like it randomly invents operators, Airflow operators that don't actually exist. But that's the process of getting that back into Airflow, back into our vector store and fixing that up. And so there's a separate set of DAGs that capture that. I think we're using LangChain Smith, which is in beta currently, as a way of kind of capturing all that information, understanding what's going on, and then feeding that back into your database. So I'm not going to spend a whole lot of time on this or the front end today, but I wanted to give you an idea how it all kind of plays together. So in a minute, I'm going to go through, actually just show you how it's built, how you can get started, and you can try things out. In the meantime, I guess any questions? There's a microphone here in front too. Was that way too fast? Is my American accent too hard to understand? Is anybody building something similar right now? No, not yet. Your boss hasn't come to you yet? We need to do something with LLMs. Yeah. Cool. Well, feel free to jump in with questions throughout. Like, don't hesitate to interrupt me. Just raise your hand with the lights. Maybe you want to yell something or throw something at me. I may not be able to see you, but and then we do want to catch with the microphone for the recording, so we can make sure that the audience can hear it as well. So don't hesitate. Was this a hand over here? Nope. Okay. All right, so let's get right into kind of this workflow. Like I said, this is kind of a production use case. We wanted to do an open source reference implementation that other people can build with and also contribute to and make better. We're building it currently with Weaviate and OpenAI, but those are going to change. We're going to be developing more quickly with, I think Pinecone is the very next one, and then OpenAI and, Cohere would be the 2 that'll be coming out shortly. And I think you'll see throughout this process, it's actually quite easy to just switch things out. When we have the provider for Pinecone, it's like 4 lines of code to switch it out, and everything switches over, moving to Pinecone. And same thing with Cohere versus OpenAI. All of them are really great technologies. Different ones will have different expectations for your particular use case. So this is a good time. Like, if I'm going too fast, just jump in and tell me, hey, go back to that thing. I didn't understand what you were doing there. For the people trying to take videos of that, hopefully it's big enough for your iPhone picture there. So this is the repository here, github.com/astronomer/ask-astro. It's a public repo, like I said. We're going to spend time primarily here in this Airflow folder. The API and the front end is all here in the API directory. There's obviously docs and tests and scripts, and then there's a different UI front end as well. So this is a node base. You can just do npm start, and you can actually you can run the front end as well if you want. I'm going to spend time, like I said, here in this Airflow folder, which is everything that gets up to how do we take these unstructured documents, get them in a vector database, and then there is a simple testing front end that we built as a Streamlit app for you to kind of probe the data that you get in there as well. The DAGs are in, there's 2 different versions of DAGs, and this comes, again, from a philosophical perspective. A DAG, if you're not familiar with Airflow, obviously a directed acyclic graph. It's a set of tasks that run in order. And there's kind of two different versions here. This load one, which we'll work on today, which we're really going to focus on today, is taking all those different data sources that you saw and bringing them in. This is kind of like a baseline load. You want to get something started. And this is important to separate out because you're going to try things. You're going to try a chunking strategy, and you're going to check the front end, and you're going to realize it sucks, and you're going to go back and try it again. You can just wipe out the database, rerun your ingest with a different thing, right? So it's very easy to iterate and try new chunking strategies or models or front ends, different schemas as well. And so that's why that load one is kind of everything together in one. These are basically the same code, but in individual DAGs that run nightly. So the initial kind of point in time snapshot is the bulk load, and then these individual ones will go through and on a nightly basis will pull any new documents that change. And this is pretty important. The Airflow docs in particular change, I think, every night with the push that goes out. If you're using your own corporate documents, it's probably going to be even faster. If you think about, the pace of business and changes within the business, you need to be able to do these things very quickly. This is using the Astro CLI. So there we go. I think this is the most recent one. The Astro CLI. So Astronomer, we have, like I said, a hosted version of Airflow. So you can just try astronomer.io. There's a free trial there. You can try it out if you don't want to build and run your own Airflow. But the CLI also allows you to run a local version of Airflow. It's a Docker Compose-based framework. So it just builds local Docker containers with everything you need for Airflow. It's about 5 minutes worth of work to get everything up and running for a local Airflow instance. Like if you've ever looked at the Airflow docs and the actual installation process, it can be kind of painful. But there's a Docker-based runtime we create, and it all runs locally. And like I said, it also integrates very well with Weaviate. And so here in the Docker Compose override, you just make a file here, add in the Weaviate container. This is on their public website, so you can see that there. And then you've got a local instance of Weaviate running when you start Astro as well. So if you hear me talk about Astro CLI, it's this CLI that we created. If you're on a Mac, it's as easy as brew, install Astro. I've already got it installed, obviously. And there's instructions for Linux and Windows as well. But it's a nice kind of local development environment, allows you to iterate very quickly. I'm going to make this a little bit smaller. I think it'll be easier to read more text on there. If it's too hard to read, just let me know. I can make that bigger. So this, the README here in the Airflow directory is kind of a good way to get started. This is everything you need to know to get started. Just clone this repo, make a CD in the directory, and you've got all the steps you need to go and get this entire process built from end to end. Like I said, so the current sources that we have are the Apache Airflow docs, the Astronomer docs, which are a superset of the Airflow docs. So it's, like I said, a lot more depth, better explanations, and deeper understanding of the various techniques and frameworks within Airflow, as well as our own, like how to use Astro. That's in those blogs, those as well. Our blog posts are there. If you haven't seen the Astronomer registry, this is a great place to get started for all things Airflow. There's sample DAGs in here. All of the different providers that you're using that are out there. If you want to go in here, you can see how this provider works, the interface, et cetera. It's a really great building block. Again, this is not specific to Astro. This is all Airflow. So we take in all of those modules. I told you there's 1,534 modules currently in Airflow, and I know that because I saw this ingest run, and it pulled 1,534. So all those modules, you can ask questions like, for the Databricks operator, what are the parameters for Databricks operator? And it'll just put it all out there for you right there in front of you. The issues and pull requests from Apache Airflow, Open Lineage, if you're not familiar with it, has a tight integration with Airflow as well for data lineage, and so those docs are in there. The open source Slack channel for Airflow. So the troubleshooting channel specifically in the Apache Airflow Slack organization has a lot of great knowledge in there. But again, you don't want to be searching in Slack for answers. It's not a lot of fun. Also, this is obviously an open source project, so we're using the free version of Apache of Slack for this open source framework, which means it has a 30-day memory. Also, it cuts off after 30 days. The Airflow community has created an archive website, if you're not familiar with it, slackarchives.org. And you can go back and find all of the Slack messages going back to 2018 or something like that. So kind of an interesting tool a lot of people have never heard of. So we're indexing all that as well into Ask Astro. And then Stack Overflow as well. Stack Overflow has some, if you're building your own use cases, has some limitations. I think they just implemented them recently. You're not allowed to use LLMs with Stack Overflow currently. I don't know what they're going to do with that, but obviously they've created their own models that they want you to use instead. But what you can do, the Stack Overflow, they do a public dump to the Internet Archive. So the terms and conditions are whatever's in the Internet Archive. So you can pull these periodic Stack Overflow dumps from the Internet Archive. They're huge, and so you have to process them and get them into a certain format. But you can go and look at any kind of old Stack Overflow sites from a long time ago. And I believe the public use, check with your lawyers, obviously, the terms of use are very different than the Stack Overflow one. So all those different resources, like I said, there's a bulk load, and it looks like this. All these different data sources coming in. There's two different types of splitters, one for Markdown documents and one for Python code. The split framework that you want to use is going to be a little bit different in there. And then both of those feed into a single ingest, which imports the data into the Weaviate vector database. To build this, literally all you need is Docker Desktop, and I'll show you why in a minute. If you want to do your own embedding and things like that, obviously you need an OpenAI API key. If you want to push to a production environment, you'll need a Weaviate. In this case, again, this is based on Weaviate. Weaviate has a great free sandbox trial version, and Astro has a free trial version as well. Both you can get up and running with free stuff for 14 days there, which you can see this kind of process of pushing to production and a hosted environment. So again, the installation is as easy as brew, install Astro if you're on a Mac, or the Linux equivalents are there as well. And then there's these environment variables, which you'll see in the code. This way, we can move very quickly between local development in our local containers locally, try things out. Again, you're going to iterate. If you're building these, you're going to be iterating. You're going to realize how expensive GPT-4 is. Like initially, it seems great. You can just go, let's just feed it all into GPT-4, and you realize, oh, okay, that's really expensive. Let me try something else. And so, just being able to try different things, this local development environment is really important. If you're not familiar with Airflow connections, you can create the connection strings to connect to things like Weaviate, that's quite small, to Weaviate or to GitHub for pulling the GitHub information. You can keep Slack, etc. All those are in connections. And the connections are part of these integrations that we have with them, where it's very easy to come in here and make a new connection for, like I said, we created a new provider for Weaviate. You give it a name, and then fill in your token, API token here, and you've got an integration with Weaviate, which can be used downstream. Or you can do them all in environment variables, which for the sake of kind of a workshop or something like that, is just a little bit easier to put it in there. And so you'll want to be able to create something like a .env file in your project directory, in this Airflow directory that has those environment variables in there, and they'll look something like this. Again, this is all in the README, so I won't bore you with going through line by line on there. Go back here. So so creating these environment variables that are in there, obviously to be specific to your use case. If you are doing this with GitHub, so all the GitHub pages in this repo are publicly available, so you do need a GitHub personal access token in order to read them. You can't just read them programmatically from an API. You do need a token, but it doesn't need any permissions. So you can make a basic, very, very basic personal access token with no permissions, and it should be able to read all those. And then, so creating these Weaviate. So the Weaviate local one is just pointing at a local container, in this case, running on port 8081. And that's where you'll see that. So before we get into the schema, any questions on the connections, setting up the basic framework within Astro? No? The second day, towards the end of the day of a conference, I can see you guys haven't tried the coffee here either. All right. So the schema. So the schema is how the data is represented in Weaviate. Obviously, when you install from scratch, there's no schema there. There's in the data directory, there we go, schema.json. This is a sample schema that you can use for this particular one. This was meant to be very quick and obviously consumable by the community. And so this is a very, very simple schema. Also, just kind of as a point of kind of some things to think about, it's great to start with a very simple schema. You might have a tendency to say, let's go back to this bank example, right? So we're going to ingest loan documents. We're going to ingest, financial forecast documents, which are large structured data, unstructured data. We're going to use these different data types, and we're going to make a different schema for each one with each, which each piece of metadata needs in there, right? And you can do that. What I've seen in my experience is basically you spend months just trying to get that schema right before you even start iterating on a use case. So I suggest always start with a really simple schema. You can always change it later and start over if you set things up, to be able to do this, to iterate on this. So this schema has one single type, one document class called docs. So everything, whether it's a Stack Overflow, Slack messages, the actual docs themselves, blog posts, they all go into a thing called docs. And obviously these are different types of data sources with different types of metadata, which you can make richer, but instead we kind of just kept it with some very basic schema. So the properties are the doc source. We just give it a name, right? The source where it came from. The link, because these are all web-based data documents, they all have a link which you can treat as a primary key for upsert, which I can talk about later. The actual content of that thing, in this case, this is the chunk of data that we're ingesting, not the whole document, but the chunk of data that was split. And then at one point we had the idea to use the GitHub SHA as a way to look for changes that have happened. So on the upsert right now, the way it works on the nightly ingest, basically we just ingest everything again. We'll go to GitHub and GitHub Docs for Astronomer, and we'll just ingest everything. And then we'll use the combination of the unique identifier, which gets generated in the code, and then this doc link in order to see if something's changed. So the unique identifier is like a hash of the content. So if something changed overnight in that particular document source, we'll see it. The UID will be different, but the doc link will be the same. We'll dump it, re-ingest it, etc. So it's kind of a naive approach to update. Like we're just pulling everything again every night, and then deleting 90% of it because nothing that didn't change, right? If you're doing this, in your use case, maybe if you have something like a timestamp, if you're reading from data in S3, for instance, you'll have the update times and things like that you want to use to be a little bit more intelligent about which things you update, right? You can just keep track of update only everything since last night's update. This naive approach actually works quite well because the number of docs are pretty small. So that's the schema, and in the DAG, we're actually going to create the schema with the operator that we created. Here you specify the model that you want to use for, in this case, this is the text to vectorization model. This is with the OpenAI endpoint. In the README, there's an example of how to switch it for Microsoft Azure if you want to use that. Obviously, in the Weaviate docs, you can see how to use Cohere or Hugging Face or some of the other models that are there. And then these other modules for generative AI and Q&A, you'll see later with the Streamlit application. So that's the schema. You get that in place. Obviously, you want to set it up for your particular use case. But for this, if you just want to run this through, you can do so without changing the schema there. So one other thing I think that's important is to build baselines as well. In the bulk ingest DAG, which I'll show you in a minute, it basically takes a point-in-time snapshot. The first time you run through the DAG, it takes about half an hour because it's actually pulling all those data sources, but it saves them in your project directory as a Parquet file. So if you rerun it again with a different chunking strategy, different splitter, different model, you don't have to pull all those data sources again. And same thing with the baseline. Once you've got it all into your Weaviate database, you got it the way you like it. Maybe it's a small subset of your documents if you've got very large corpus of documents. And then taking a point-in-time snapshot of that and storing it, in this case, we store it on S3, and this is publicly available as well. That allows you to just start from zero in about 2 minutes. And so when you run this the first time, if you don't want to sit and watch it pull all the Slack archives and all the other stuff and go through the 30 minutes, step 5 shows you how you can use that point-in-time snapshot as a seed baseline. So this is also important to compare kind of A/B testing or champion challenger type of pipelines as well. So if you're going to go through and make a change to your splitting strategy, you want to be able to understand, is it better or worse than what I had before? And that's not always obvious. It's actually quite hard to tell that. One of the things you'll see that's missing here is any kind of evaluation pipeline. After the ingest, you want to have, and this is coming up in the next couple of weeks, You'll see this from us as well. Some way to evaluate that. And there's a lot of techniques. Arise is probably the partner that we're going to work with on there. They do great jobs on techniques for evaluating how good or how bad you did in ingesting all of those documents. But you do want to have some kind of a baseline, so you can say, compare this with this. Is my chunking strategy better or worse, right? This also helps with something like a workshop, because then you can go through and you can run this entire workflow in about 2 minutes, and you don't have to have an OpenAI key or anything else. It'll all run if you use the seed baseline as in step 5. So with Astro, again, brew, install Astro. You got the Astro CLI, fork the repository. You cd into this Airflow directory, and then just run astro dev start. It's going to pull the Docker runtimes for the Airflow web server, the Airflow scheduler, the Airflow triggerer, and that Weave8 uses a Postgres database as well, and then the Weave8 container for the Weave8 service. All those get pulled down. So depending on your speed, I wouldn't recommend doing this at a hotel Wi-Fi, but it'll be up and running in just, well, however fast your internet is. But you'll have the entire thing up and running with astro dev start in just a couple minutes. And then you can run these DAGs. So I'll show you the example here. I'm going to walk through some of this code here for the bulk ingest. So this one, this is where you'd set the seed baseline, put the link to that Parquet file out on S3 if you want to install from that. It's about 300 meg, so it's fairly small for an unstructured data source. But it's got all the data already ingested, already embedded with these OpenAI vectors, the vectorization, all that's already there, and then we just suck that right into Weave8 for this nice baseline that we wanted to do there. But if you're not doing that, if you do want to run this the first time, there's kind of 3 different pieces in the code, and you can see that here in the tasks directory. There we go. There are extract. A set of extract, and these are source-specific code. And it's very modular, so you can just set up new sources in there very easily. There's the actual splitting of the documents, which we'll see in a minute, and then the ingesting of those into the Weave8 vector database. So all the DAGs that you saw are all using this modular code base in order to do that. So for instance, I'll show you something that's a relatively small amount of code, the registry. So the Astro registry that we have, you can see the links here. It's got a JSON REST endpoint on it, so you can pull it from a regular Python request. But this is going to be specific to your environment. Obviously, you can come in here. You've got a different data source, maybe a bunch of PDFs in S3, right? And this, you can just write in this extract, you can write a function for extracting that specific data source from S3, and then just return it as a pandas data frame. Pardon me. In this case, I return it as a pandas data frame. One of the questions I get a lot is, well, what about this XCOM passing of data? Are you familiar with XCOM within Airflow? XCOM is the cross-communication database. So it's basically how, when we build these tasks, these DAGs of operations, and you can see one of them here, the data that's passed between tasks keeps the state. And this is what allows you to very quickly retry things, or to keep track of what changed, or auditing and lineage. Everything comes down to this kind of atomicity. Every task in Airflow should be a nice atomic piece of code, just like good modular Python development, right? And so the DAG, if you look at, this is not a very fast Wi-Fi. Okay, here we go. You can see all these different operations. When we're taking, for instance, the data that we pull for the Python code and passing it to the splitter, it moves through the XCOM process within Airflow. XCOM means cross communication. So it's this basically stateful database of what the data look like in there. It is not designed for passing large amounts of data. In fact, it really was never meant to pass bulk data itself, but more metadata about which task was doing what. So from a kind of philosophical standpoint, if you have a huge data set and you generate a whole bunch of vectors on that, you probably don't want to pass that through your XCOM database. You probably want to store that in S3 and just pass a link to that URI from one task to another one, right? But in this case, again, relatively small documents, and Airflow 2.5, I think it was, made it possible to pass actual pandas data frames between those tasks. And so for this particular use case, it's actually just fine to just pass those pandas data frames. So every source, we just extract it, put it into this kind of this well-known structure with having a document source, the SHA, whatever that is, some kind of a UID hashable type thing. Again, I probably would take that out at this point. We've thought about using GitHub SHA as our checkpoint to see if something needs to be upserted, but it doesn't really do a lot currently. But primarily the doc source, the doc link, and then the content, just returning that data frame. Any questions on that? So each one of these extract, again, depending on the specific source of what it's doing. The GitHub, as an example, I think one important thing I think is worth mentioning. Airflow dynamic tasks in Airflow allow you to basically generate dynamically a set of tasks over some kind of an iterable object. So in this case, extracting GitHub data from a repo is actually the same, regardless of whether it's your repo or my repo. So that extract code in the module there is the same. What we want to do is just point it at different GitHub repos. So for instance, I wrote this originally, the first time I built it was with just the Learn documents and the Astro documents. And somebody came along and said, shouldn't we also pull in the open lineage because that's useful and there's a lot of overlap between them? I said, sure, no problem. I just added one line here, reran my DAGs, and then I pulled in another data source. So keeping this modularity and this dynamic nature, the whole repos are set up with that kind of dynamic nature in mind. The web pages are not, because they're very specific format for that particular web page. But the blogs, for instance, you could point it at any blog site and it should be able to pull that data in, ingest it, and pull it over, and you can just dynamically iterate over whatever you want to do in there. So if you have your own GitHub repo and you wanted to add your own Slack bot on top of that GitHub repo, you should be able to clone this repo, start Airflow, add another line in here with your repo, and then make sure, obviously, your GitHub token that you use for the connection string should have read permissions into that repo, but that's basically all you have to do, and you can create a Slack bot over the top, or a generative AI interface on top of your GitHub docs as well. And then the Airflow docs, for some reason, are in RST format instead of Markdown. Kind of painful, but that's the way it is. So it's a different set of tasks that will ingest RST, and then use PyPandoc to convert that into Markdown. So if you see that in there. I'm not going to go through every single source here, but just to give you an idea how you can quickly kind of add your own sources in here, or if you have your own extract logic, like I said, pulling from S3 or something like that, that you can build there. The extract tasks, this is, so if you've used Airflow a while ago, you're probably using what we call the OG, the original gangster operators. The OG operators from previously, there was kind of an operator, a Pythonic functional process for building your tasks. In Airflow 2.0, I guess it was, the task flow API. You can just simply decorate another Python function and it builds the task for you. And that's basically all you have to do to make these DAGs. And then you can set the input and output from each function, get parameterized, it gets built very quickly. Anybody using, I always like to ask this, there's a divide between people who really prefer the old operators, because that's what they grew up with, and then there's like people like me who are like, no, I don't want anything to do with it. I want task flow. Is there task flow? Task flow? Any OG people in here? No? All right, good. So then you'll see, you'll understand this workflow pretty easily. The Weaviate provider that we created does have operators as well. If you prefer the operators, there's both operators and decorators, but the task flow decorator. So this is where I was saying we're basically going to read from that extract logic, return a data frame, and then with this try logic, we're basically saving it as a local Parquet file. So if I run this, the first time I run it, it takes about 30 minutes because pulling all these docs from everywhere. You saw in the graph what all these different data sources that are out there, and then because it caches them, we don't hit the limit. So another thing to keep in mind: a lot of your endpoints are going to have API rate limits, and so make sure to set retry in your task. So you can see in the task down below there it says retry 3 times every 10 seconds, and that's really around limits on the upstream endpoints. And we save that locally. So then the second time we come back and run that DAG again, we don't have to wait for all the extract. We can say, oh, you know what? I really want to use maybe I don't trust Michael, and I'm going to try the Markdown text splitter instead, and our Markdown header splitter instead. Let's run that, but you don't have to rerun all the extract. It just will pick up those files there. So this allows you to really iterate with separating your extract logic from your ingest and your splitting and ingest. If you've never seen an Airflow DAG before, there's nothing more boring to present at a conference than to look through Python code, so I'm not going to do this. But if you have any questions about how this works, I just wanted to give you an idea how you can kind of optimize it or change it for your own use case. The easiest one by far is if you have your own GitHub repo and you want to use some kind of ingest a generative model over the top of your of your data. That's super easy to just add one line at the top of this, and you don't have to ingest all the Airflow stuff. You can just get rid of these other ones to ingest these other. And same thing with Slack too. This is also very easy because it's a very well-structured format within those the Slack API. So if you have your own Slack channel that you want to ingest, you just have it. You need an API token, and again, that should have read access into your Slack channel. Yeah. I'm sorry, I can't hear.
With Confluence, it's also easy to get the information that is in Confluence.
From which one, I'm sorry?
Confluence.
Confluence, yeah.
Yes.
Yeah, and in fact, there's actually Confluence operators with Airflow as well, so you can just use those directly. Like I think you don't even. I think there's providers now as well, and Notion too is another one that comes up. Notion documents, same thing. So there's Airflow providers that are already there. You just pull that in. I wrote these extract logic for each one of these. I wrote it kind of individually, like the GitHub one, for instance. I'm using the GitHub hook, so I don't have to pass. Like the hook at least will get my connections parameters and all that stuff. Like I don't have to hard code that into my code. It'll use the Airflow connections in order to do that. And then it's got already in the hook, it's got a lot of the logic that I need to be able to, I just get repo and get contents. So it's really easy. Same thing with Confluence, same thing with Notion or many others. There's a good chance one of those 1,500 operators that are out there. You know what, let's do a test. Let's stump the chump here. Ask Michael said there was an operator for Confluent. Let's try this. Don't prove me wrong. This is still the delay from GPT-4. Yeah, here we go. Well, Confluent Kafka. All right, so maybe a little bit of a hallucination there, but it's down. It's going down the right path at least. Yeah, I had somebody ask the other day, can I use this to ingest all the Uzi documents from Apache Uzi? I said, yeah. Why would you want to do that? Because we can't get off Uzi fast enough to move over to Airflow. So, okay, so you want to use an Airflow DAG to ingest Uzi documents? Why not? That's fine. Any other questions? I was going to make your point on. Oh, yeah, so okay, so like I said, the fastest way to come in here and do this is to use, I think I've still got it in my buffer, no. To use the seed baseline, that URL that's in the README. It takes about 2 minutes, you get all your documents ingested. You can sit and watch the extract happen if you don't trust me. You put in your OpenAI key, put in your GitHub token, and you can watch all that work through, or you can just use the baseline. Once you've got it there, what next? What do you, like, how do you, okay, again, data engineering demonstrations are the worst because, like, okay, the data's in a database. Great. Now what, right? So I did build a very simple Streamlit application on the front end. It's not really meant for user-facing. It's more for the builders to be able to query it, check it out, try it. Like, what does the end user interface kind of look like and what type of stuff are we getting there? So to use that, I don't think I have it running here, so we're going to do this from scratch. So in your project directory, in that Airflow directory, so in here, you'll see that there's like this Astro. So if you're starting, by the way, a brand new project, like this one is already created, I already created this, but if you're starting something brand new, is do Astro dev init, and it'll put the stubs in there for some of the hidden files that you need in order to make a new one. So if you're starting from scratch, Astro devs, brew install Astro dev init, CD into the directory it made for you, and then Astro dev start, and you've got Airflow up and running for a brand new, clean, pristine project. This is already existing, obviously, so you can see there's this .astro file here, which tells you that's there, right? So you can see Astro Dev. So Astro Dev is just the local development environment. In the README, if you do want to try the kind of deploy to production workflow, that's all in the README as well, and you can go through that process, but I promise not to do anything commercial here today. So that's there for you later if you want to do it. But Astro Dev is about everything locally in this environment, and you can see that I have my Airflow, my web server, scheduler, trigger, Postgres server, and that Weaviate container all running locally. And I can do Astro Dev bash, mine is W to the web server. I'm going to this is just a front end into Docker exec. And so now I'm running inside, just make sure my environment variable is pointing at the right place. Yep, locally. So it is one thing to be a little bit careful of here is if you forgot to change that in your .env file and you change it to dev or prod, you just always kind of want to check before you do something that might blow up a database. So here it's pointing at the local environment here, and then get that string. So we've got everything ingested. I'm going to fast forward all the way through to the end here. And it's got all this process again about trying different documents, trying different things. You can experiment with it. And now you want to just kind of check and see what's running. This simple Streamlit application is there. Starts on port 8501. 501. There we go. And this is using the same connection string from Airflow. This is why I'm running it in the container from the web server, just because it's easier than trying to pass my OpenAI keys and Weaviate tokens, et cetera, around. So I'm running it from the web server container itself. And so I can read that connection string from there. So just links here if you want to read about what these things are, but essentially different modules within Weaviate, and then also LangChain example as well. So you can do Q&A. So this is simply going to, it's Command Enter, I always forget. Simply it's gonna take this question, how can I use dynamic tasks? It's gonna use the embedding model from Weaviate to vectorize that question, then do the similarity search. And it's gonna find these documents, which were all, these document chunks, important. These document chunks, which were all related to my question, and the links to the actual documents are down here that you can see. So it's going to point me to Slack, in this case, a Slack message that somebody provided for that. And so this is just Q&A. It's just finding these documents are the most related to that. So this is useful for troubleshooting and evaluation. If you're seeing some weird behavior, you can actually put in the actual, like if you get some strange hallucination, you can put in the strange hallucination answer from your front end model and go and find what are all the documents that it thinks are related to that. Maybe something happened during the ingest. Maybe your splitter made a really bad choice about where to chunk a document. Those are all realistic possibilities in there. But this is pretty simple. This is all locally, just looking locally against the database for those documents that are there. Weaviate also has a generative module. They have a re-ranking module. They have several others too, and you can go see them in there. All of this code is pretty easily available. You can see it here in the Streamlit folder. That's pretty straightforward Python code in there. The generative model does the same thing. Again, it's going to vectorize the question, do the similarity search locally, and then they take care of Weaviate. Actually, internal Weaviate takes care of the process of building a prompt to say, here's the question, use this as a context in order to answer the question. It does not optimize for this specific thing. There's almost, it's a very simple prompt. Obviously, there's nothing specific to this use case like Airflow. It's still running. I always forget how long GPT-4 takes to respond to things, but it's pretty simple, kind of zero-shot approach with GPT-4. We'll see how this comes back. Any questions while we're waiting for GPT-4? Yeah. There we go.
Hi. How it would work or how often are you updating or checking for new documents?
Yeah.
And how it would look like on an event base if in case we want, like, for example, in a e-commerce application to have like near real-time retrieval?
Yep, good question. So like I said, there's a couple different DAGs that we have here. This one that I've showed you and I've really been focused on today is really kind of that initial kind of bulk ingest, get things started, right? And I say bulk, but actually when you set it up, you might want to set it up for just grab the top 20 documents that you want to do or something like that, right? Because again, you're going to iterate through this ingest and try different things over and over and over. And if you ingest all 10 million bank loan documents over and over, the only person that's going to win is OpenAI, who's taking the embedding model is like 0.002 cents per token or something like that. So it's very inexpensive to re-embed a bunch of documents. But with this bulk one, it's good to start with just do a pandas and then take the top 10 lines or something like that. So you're only doing a couple to try it out, right? It also helps with troubleshooting. So if you see something weird, you don't have to go look through 10 million documents to find out what that was. So that's the bulk ingest. And that helps with development, with this CI/CD process, et cetera. The same exact code from the extract, ingest, and split is being run in these other DAGs here. So all these other DAGs, you'll see that it's a much smaller subset of that just for this particular data set, right? This Astro Blogs website in this case. So these are running every night at, I think I set it for 5 a.m. UTC time, just because the backup window, so I'm using the Weaviate hosted instance for my production environment, and they have a backup window at like midnight UTC, and I just want to make sure it's done before that's over, whatever. But in your case, if you're talking about an e-commerce or something that has to run much faster, obviously you want to set that time frame a lot lower. And if you're not familiar with how to do that in Airflow, basically you set your scheduling interval here, and there's a ton of documents. This is really kind of the simplest way, 5 a.m. UTC every day. But there's a lot more options on how you can do that more frequently or faster, et cetera. And the best way to get your answer on how to do that is to ask Astro. How do I set up scheduling for every 30 minutes? Good question, though. Any other questions? You want to see if my generative search actually returns something interesting, right? All right, so in this case, you can use dynamic task mapping to generate parallel tasks. So this is a generated answer. This is not an actual text response. So in this case, we took just those top ones and did a redirect over to GPT-4 for one answer. So did you have a question?
The environment is like local. Do you still have to like put the whole like docs from GitHub or everything in the LLM and embed them and find ask prompt?
Yeah.
Isn't it like still costly like doing this locally?
Sure. Yeah, so like I said, this local development environment is really just for me. It's for iteration, for trying things without running up cloud costs, et cetera. In the Astro world, when I'm ready to now run this in production environment, I just do Astro deploy. It'll take those same containers. So Astro uses a container-based deployment process. Take my containers that I'm running locally, push them up to the cloud, and you use those as that hosted environment there. And I think your question really is about, like, do you re-ingest everything again, right? So I don't actually run the nightly ingest tasks locally. Like, I'll run them every once in a while just to try them out, make sure they're running right. But what runs in production, there's also a production version of Weaviate. Obviously, I'm not using my local hosted Weaviate. So yes, everything looks good here locally. I got this trial, I've gone through, done all the ingest. Now I said, now what do I want to do? I'll change that one environment variable from from local to dev, make a new, let me just show you here. Make a new connection string for my actual Weaviate instance. When you create a Weaviate instance in the cloud, it gives you a URL and a token, and then I push that, and now it's going to run through those same DAGs and then put the data into my Weaviate hosted instance, right? Yeah. So again, that's all now my production environment. I don't touch it. That's running there, and every night I go and pull all the documents from all the Slack messages, everything, and anything that didn't change. So it'll be able to do an upsert check in there. If it didn't check, I just delete it. I don't try to ingest it again. Yeah. Is that your question? I think maybe not exactly.
Yeah, it was similar. Like, I think it was kind of also similar to the question back end.
How often? Yeah. Yeah. Mm-hmm. Yep. So that's the generative module within Weaviate. Again, it's kind of like a zero-shot approach in there. And then also I have an example here of using LangChain. So LangChain can use the in-memory vector database or vector store for a lot of the LangChain. Like in the initial prototype we had, it was all in memory. Actually, I think they used Face for the vector database initially. the initial code. And then, but you can still use LangChain with an actual production vector database as well. And so this code is basically the same. You can ask it the same questions, but now instead of, so the other one, the Weaviate generative, what I do, I'm just talking to Weaviate. I give Weaviate the question. Weaviate takes the process of embedding the question, checking locally, talking to it. That's all happens between Weaviate and OpenAI, right? In this one, basically I'm doing it wherever this is running, in this case, the web server. I'm going to talk to OpenAI directly to get the embedding. Then I'm going to talk to Weaviate, check for the closest documents. Then I'm going to pull those back and then send them to GPT-4 for the generative answer. So again, more or less kind of the same flow. It's just a matter of whether you want Weaviate to do it for you, if you want to use LangChain. In the LangChain example, we actually have, I will go ahead and run this. So in the directory here, there's a sample prompt. Streamlit, where's my Streamlit? There it is. There's a sample prompt in here that you can use as a starting point. Again, you're Ask Astro, you're a friendly, helpful bot. Here's all the context that you need to know, what you should or should not do. And then when Weaviate calls this, it'll drop the question in here and ask, along with the context, this is all the search results from our vector database that go into the context environment. And then this is what gets sent to GPT-4 eventually, finally. And you should see that here if this is done. This is actually probably a little bit slower because of the conference Wi-Fi more so than GPT-4. So this is the Streamlit app, like I said, is just a troubleshooting tool for you to use. So you can, if you look out on the internet today, there's 10,000 Streamlit apps for LLMs and different chat interfaces and everything. You can use those as well, but just more for you to have something running locally that you can use. Why did it not? It should have given me the prompt here as well. Huh, that's interesting. I wonder if I broke something earlier. In the output, I also said, here's the prompt that was used to generate this, so you can kind of see the results in there. I have to look and see why that's not in there. But so a couple different examples. Again, you can take that, you can change them. If you want to do something more interesting, like actual chaining, like chain of thought, you can do that in there as well. We just wanted to give a starting point so you can kind of get started in there. So, what other questions? I would love for somebody to tell me this is a really bad idea, or come on, anything, right? Like, this is such a waste of time. I shouldn't have. So yeah, like I said, I mean, the whole point of this is we were building an internal use case. We had a lot of people coming to us and saying this exact thing. Somebody handed me a notebook. My boss wants to do something with LLMs. We already have Airflow in place. We've got 10,000 pipelines running every day, millions of tasks. We're training models. We got all this infrastructure already in place. It doesn't feel right to me to go and reinvent a whole bunch of stuff in new code when this can help me, you're already doing this. What does that look like? And so that's why we built this. We built it, it's publicly available for everybody to be able to try it out. And even if it just saves you 10 minutes getting started on a new use case, like that's fine. We would love to hear from you though. Like if you do try it, if something's terrible, if you have ideas, we love pull requests. If like I said, those extract modules that are in there, if you built your own for something else, like pulling PDFs from S3, send a PR. We'd love to integrate those in there too. Other people can take advantage. This is all community development work. So definitely try ask.astronomer.io. Even if you're not doing anything with LLMs, if you're using Airflow and you have questions and you can't remember things, that's the quickest way to get started. One announcement, we're going to be integrating the Slack bot with the Airflow channel. So the open source channel, you'll see a Slack bot in there. In Airflow, there's an Astronomer section, Astronomer channel within the Airflow community. And in there, you'll have the chat bot in there as well. I don't prefer Slack bots. I like the web interface a little bit better, but it's there for you. One of the benefits of the Slack bot is you can see what other people are asking too. And you can ask, you can look and find search results, searching in there. But by all means, fork the repo, try it out, send your PRs. If you want the Airflow Weaviate provider that we built, it's in beta right now because it hasn't been released yet, but it's there. And it's also in the project repo as well as a wheel file. It's not yet on PyPy just because we haven't got it finally out there, but there's a wheel file there with all the operators and everything you need for ingesting there. So maybe a quick, I think I have, Yeah, here's the operators that we have currently within there. There's the import data operator, which is used in this, actually the decorator, the task flow decorator. The create schema we're using. There's a check schema and check schema branch operator, which are also used in there as well. If you're not familiar with the branch operators, it simply branches on some kind of branch logic. If the schema is already in place, take these tasks. If it's not in place, go ahead and create it. I use the retrieve all operator in order to get that baseline, that seat baseline that's out there on S3 right now. So that kind of makes a Parquet file dump of that. And then the backup and restore operators are great for local containers. If you're using the hosted instance from Weaviate, they do all that for you, so there's nothing you need to do on there. And like I said, there's task flow operator version of the import data as well. Any thoughts? We have 15 minutes, so I'm going to stand here and drink water for 15 minutes. Although we're in Portugal, we should be drinking port, right?
Yeah, so like I'm kind of curious about like the question and the like finding the answers in the doc based on like the embedded similarity. Like is it how does it like how does the similarity of the text of the question find like the answer, because it's not necessarily similar text, but
it's not an exact text search, right? Yeah. So by the way, Weaviate does have a hybrid search option where you can do the vector search, which is what I was talking about, and then also do an actual text search across metadata fields or something like that. And so it's very powerful. You can actually get much better results by combining those two together, right?
Oh, so it's on the embedding itself that it like.
Yeah, the current way, everything here, I haven't set up the hybrid search for this particular example yet, but so the Q&A is literally just. So again, So a couple things. One, I'm using the modules inside Weaviate, so I'm not actually implementing any of this logic. I'm simply I send a question to Weaviate, and then they do all the rest. But it's open source, so you can go and see what they're doing in there. But essentially, they do the same vector embedding of the question. They get this vector, 1,536 degree vector of what that question is. And then it's just a cosine mathematics. It just looks through all the vector. It's an inverted index, right? It looks through all the existing vectors to see the closest ones.
Yeah.
Is that what?
Yeah. And I had just a thought about like this module, like it pulls like all the doc results.
Yep.
Like I was thinking like like for a Stack Overflow posts and like Slack posts, they're like similar type of like everyone asks and answers.
Yeah.
But for like docs, it's like in one place.
That's right.
So it could be like two different like type of docs.
That's right. So actually, yeah. So I don't know if this is the best way to do it, but it seemed like the most logical to me when I was building this. So by all means, if somebody has a better way, I'd love to hear it as well. But you're absolutely right. In Stack Overflow, the API is actually, I don't know if anybody works for Stack Overflow here. The API is a pain. And you get, there's like 5 different types of objects. There's the original question, then there's the comments on the question, then there's the responses and the comments on the response. And so it's just a whole bunch of messy stuff in there. And if you look in the Stack Overflow logic here, you can see I have some helper functions in here. But it was actually pretty ugly. Basically what I did is pull all that together as a thread. So I took the original question and then populated the comments. And this isn't a markdown document, so I can do the headers at different levels, right? So I've basically created a markdown document which represents that entire thread. So it has the original question with the comments and each answer with all the comments for each answer all together in one big kind of markdown document. Yeah. So this is the way I was telling you before, is kind of taking this kind of ugly, like messy API about all these different things and putting it together into one context-specific document.
Yeah. Thanks.
Yep, that's a good question. What other, I'm always curious, I ask people, what are some other data sources that might be interesting for this type of thing, right? Like something that's in the public domain, GitHub repo, GitHub docs, those type of things, Stack Overflow, Slack. There was an old forum channel too that was out there. It has some old something to be aware of. Obviously, garbage in, garbage out. So there's this old one and it had a bunch of old answers that were out of date in it, and they wanted us to ingest that also. We said no because it has a whole bunch of wrong answers in there, and then your model, your LLM is just going to pick up on that, right? So, yeah. I'm trying to think of any other data sources where, yeah. Does anybody have any use cases you think you could start and just try, like fork it, apply your new logic? You got something in mind already?
I'll try using it with some NVIDIA projects. The documentation is really bad. So.
Yeah. Yeah.
Maybe, I'll try it.
We have some doc writers on our team too, and I don't know if there's any doc writers in the room here. They're the unsung heroes of the world of pulling together logic and making engineers actually do their job. And so some interesting ideas. Like a lot of the world's documentation is pretty ugly. And there's some interesting ideas. We're thinking about building some new Airflow operators that'll do kind of almost like a Rosetta Stone of conversion from, you got RST and Markdown, and you got Word documents in XML format and all this other, like, how do you get that all into one kind of consistent representation of data with metadata? So we got some ideas on that, but yeah, you're right. Yeah, interestingly, LLMs are actually quite good at pulling that together. If you can at least get the context, like here's this idea, this concept, and everything in this document is related to that concept, the LLMs can really pick up from there. The problem is if you have one document with 10 different concepts in there, it gets pretty hard to pull things together. So, you mentioned Confluent a little bit ago. Is that something, I'm curious on that. When you think about a lot of like Kafka topics, I guess if you index it at the topic level, that could possibly be interesting. I guess every single message would be hard to have. Yeah, at the topic level, yeah. Yeah, I think that's a really interesting. Yep. Yeah.
We have that documented in a bunch of places, so it's, it's a very good use case. And you are using already Astronomer. So.
Okay. Yeah, and if you do end up building an extract logic for that, that would be a perfect one. Like it would fit really well with this, right? Like you got a Kafka topic, and there's a lot of work that went in. Recently, we worked with Confluent a lot to build those operators. Some of my colleagues were working on that as well, and just being able to, at a topic level, that actually could make a lot of sense because the message provides a very nice split barrier, also, right? So if you set a 1,000 token limit on your chunk size, and it'll split right at a message level, you're not kind of cutting off a message halfway through or something like that. Yeah, that could work really well. Good. Great. Well, again, I would love to hear from you. How like, is this useful? Is it beneficial in any way? My email's here. By all means, shoot me a note. Look me up on LinkedIn. And if you see any bugs in there, it wasn't me. It was somebody else on the team. So, good.